into today's lecture, which is about collaboration. So today's collaboration. Next week is going to be about screwed up Scrum implementations. So if you're interested in seeing how Scrum implementations can screw up after spending the semester trying to do it in your teams, I have a whole bunch of examples of companies that mucked it up. But today I wanted to talk about collaboration. And last week, in fact, there were some people describing to me interesting concerns they had in their project teams about collaboration and stuff like that. So I thought that would be an interesting theme. But also, I just spent the weekend in London, England. Yes, I went there for the weekend. And, hello, is that mine? Yes. And I was working with some people, basically Dorothy Graham, who is quite a well-respected person in the software engineering world. And she's published dozens of books on various aspects of software engineering, has participated in standards boards, and does all sorts of consulting and training work. And basically, I'm working with her on some stuff on collaboration. How do people work together? And this fits into Agile project development quite a bit, because when we look at the Agile Manifesto, this is the raw Agile Manifesto. So remember we did the manifesto, first class or something like that? It says, individuals and interactions are valued over processes and tools. Individuals and interactions. Which individual are we talking about? We're talking about the team members. We're talking about the team members working together to try to get the software done. Working software is more important than comprehensive documentation. So we're not worried so much about the paperwork of a software engineering process. We care about getting the working software done. And if you look at traditional lifecycle models like waterfall models or spiral models or rational unified process models, all these different models have tons of documents. Some of them have up to 75 software engineering documents defined. And the way people work together in those projects is they sort of create a document. And then, so if you're designing software, you'll create a design document, and then someone will implement the software by using the design document. So you have all these sort of, some people create, some people use, chain going on of documents. But in Agile projects, we really go against comprehensive documentation. So we have to figure out ways of collaborating without a lot of paperwork. Customer collaboration is valued over contract negotiation. So the importance of dealing directly and frequently with the customer we need to is an important part of Agile development. And of course the last bit is responding to change. Perhaps responding to change is not really in itself about collaboration, but responding to change effectively means we have to really communicate and react to that change in the team. So there's a lot of collaboration items in Agile projects, and I think that in fact collaboration becomes a critical success factor to actually getting software developed. And it's not so much the individual skills. It's not so much, hey, I have this software developer, this programmer who is a hero, who's a superstar at a certain type of code, and therefore we're going to develop great software. It's actually the successful team is the team that can collaborate with a group of people and not necessarily have to rely on the heroic efforts of any one individual. That said, I'm not suggesting we don't benefit from having people who are superstars in different technologies. It's just that we can't sort of ride on their coattails. It's got to be basically a team effort. When I pull a definition out of a dictionary, I sometimes prefer to go to the Canadian Oxford Dictionary. Which one do you guys use? What dictionary is your favorite dictionary? Do you have a favorite dictionary? Internet. The internet is a favorite. What's that? Dictionary.com? Oxford, yeah. The one I like is Oxford Canadian. The Oxford Canadian Dictionary has the American definitions and the British definitions and the sort of Canadian definitions all mucked into it. So that's my favorite. But online, I think that the best resource is Webster's. So I picked Webster's. What does collaborate really mean? And if you look at the definition that comes out, it's very simple. To work jointly with others. So two or more people doing something together. So it's not the individual, it's the two or more people. And with others or together, especially in an intellectual endeavor. So we're doing something, we're creating something, it's a cognitive process that we're sharing with others. Now, I think collaborating could mean just working together, but here the sense we have is we're creating something. So we're not just dividing up the work so that two people can do it. Like, for example, here, you carve the stones and I'll put the mortar and we work well together. Yeah, that's sort of collaborating. But what I want to do is I want to sort of say, let's figure out how we're going to make these stones into the object we want and figure out how to organize it, sort of turn it into more the intellectual endeavors. So this is where collaboration comes from. In Scrum, so I'm going to be specific about Scrum. Most of my experience is Scrum, but there's also some variants on Scrum I'm going to talk about here. Well, these are the points that I've identified where people have to collaborate to get work done. And there's about actually 20 different, what I call Scrum collaboration points. Places where two or more people combine their efforts to get things done. Now, and excuse these slides, they're just raw text from a mind map. I didn't put artwork in it or anything yet. So the first one is grooming. Grooming in Scrum is basically working with the product owner to have really great stories in the backlog. The idea of grooming a story is to basically have a story that we can estimate, we can understand, we can communicate well. So grooming is a collaboration, sort of a twofold collaboration. People usually have a grooming meeting. It's a physical meeting with a bunch of people. And the product owner is there. So the person, the customer, the actual customer is in the room talking to you. And the team, the people who will be charged with implementing it, not some other strangers who are good at estimating things, but people who are going to actually be responsible and committed to developing the software are there. And they meet and they discuss things and they try to really get a good, solid understanding of the stories. Now, how can we understand a story? It's part of it is discussion and dialogue. Part of it is questioning. One thing I put up there, for example, something called affinity analysis. So you see this new story, and the story says something like, well, we're going to, buy a book on Amazon.com. And you might say, okay, I learned this in Sesame Street. I know sometime in my past they said one of these things is not like the other and one of these things is the same. And we're going to do an affinity analysis. We're going to say, that story is similar to something I've done in the past. Now you might not have something you can grab from the past, or it might be a stretch, and it might be a team discussion to sort of anchor what the story is that the customer needs against something in your past that you've actually done before, so that we can basically sort of talk about it from a common ground. So we're not all hitting it from different directions. If you've never implemented buying a book on a piece of software, well, you might have implemented some other transaction on some other system and say, well, that's a type of transaction. We did a transactional system before. So what's different from that transactional to this? And by comparing it and saying what's the same and what's different, we get a better understanding. So the dialogue between the product owner and the team is very often that sort of thing. What is different from relevant experience? What is the same as relevant experience? And that's a sort of an affinity analysis. Now, do we have to document that? Not necessarily. There's no need for necessarily a persistent document of that. But by having this dialogue, we probably will be helping the owner wordsmith the text. Because if when we say, that's similar to this, they'll say, no. It's very different from that. Aha! Then we've triggered a thing. We're going to change the definition of the story. We're going to clarify it. We're going to make it a little bit more real for the owner, because the owner's going to say that's not the same. Or that is the same. We will improve the story definition. So all we're doing in this discussion is not creating a new artifact. We're just, if the story isn't clear, we'll rewrite it a bit so that it becomes clear. We can also look at how the story relates to different users. So let's say someone says, buy a book on Amazon.com. Well, we're adding buy a book on Amazon.com. There might be all sorts of considerations. You might say, how does that story relate to administrators? Is there a book buying administrator somewhere? A database administrator, a system administrator, a purchasing department, an auditor, or some sort of a persona, different types of things we can look at when we're trying to understand a story. we can sort of look at it from different perspectives and try to understand how the story relates to other types of users. Also, when we're discussing it, we might also try to understand how it relates to other types of objects in the system. So if your system includes a database management server somewhere, and we're adding a new type of transaction, well, you might say, well, from the database object perspective, I wonder what data we have to have. Is there a structure we have to have? Is there a new mechanism in there? And then once you've got that, there's all sorts of cool issues, because you can say, there might be process-related stuff that we have to consider when we're adding this story. The understanding of what's required in the story improves by having the dialogue looking at different perspectives. So if you look at now the collaboration, sort of the product owner is a little bit on the spot. Right? The product owner is being challenged with all these things. And sometimes the product owner says, well, I don't know. Now, is it the team's job in the grooming session to come up with the answer to that? Not always. I've seen grooming sessions where the product owner is working and they're going through a story and they come up with a thing and the product owner says, wow, I really don't know. So they'll say, well, let's stop, take that story off of the list now, learn more about it, because you can't ask us to implement that unless we have sort of some of these answers. Now, sometimes it doesn't matter. It doesn't matter is different from I don't know. I don't want to waste the product owner's time finding an answer to a question that doesn't really have any bearing on life. When we're talking about the relationship of the story to other objects, we can sometimes draw a chart or a picture and say, here's all the objects in our system. Here's the business layer. Here's the data layer. Here's the presentation layer. And suggest which aspects of this layer the story relates to. So we identify the objects of the system and say, well, what parts of the story relate to these objects? And sometimes, as I said, data comes in too. So the question is to understand the story, affinity, perspectives. In grooming, we don't just want to understand the story, we also want to disambiguate the story. We want, on our team, not everyone on the planet Earth. That would be a bit extreme. Our team would like people, when they read the story, to have a common understanding. And I know some people are worried about software requirements and they're saying they're ambiguous and two people can read the requirement and interpret it differently. I'm saying, well, what I'm concerned about is the team. So there might be some words that we want to avoid using, or some things that are ambiguous. So we want to basically read it and say, are there multiple ways to interpret this? Have you ever heard the poem, Mary Had a Little Lamb? Mary Had a Little Lamb. You've heard that one. Okay, so this is a poem that's used by people who teach software requirements. And they take the little teeny weeny poem, Mary Had a Little Lamb, its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. They wrote this four lines. And then they take that and they show you all the dramatically different meanings that are possible from it. For example, if you said Mary had, the word had, what does it mean? Does it mean possession? That sounds like it. Maybe you're assuming it's possession, but it could also mean that Mary was trying to trick the lamb, because someone had someone, you conned them, you tricked them. So Mary had a little lamb. Now, wouldn't you say she had a little lamb? Was that she just ate it? Because you can say in English, I had a little steak, I had a little potatoes, I had a little lamb. Mary had a little lamb. She had a little lamb for supper. So that's what it says. Mary had a little. Was she eating the lamb? I don't think she was eating the lamb. I think the next phrase suggests that she wasn't eating the lamb. But there's all these different ways to interpret it. And so what people do, and they try to take that phrase and look at the 10 billion ways to interpret it. And then they say, well, maybe we should, in some requirement, write it in such a way that suitably trained people familiar with the domain don't derive multiple interpretations. When I look at any story, I just ask the question practically, can we draw multiple meanings from that? And if so, then we ask the product owner, which one of these multiple meanings should we be concerned with? And then it's not good enough. If you just think about it, 3 lines, like, as a user, I want this for that. You sometimes have a lot of possible meanings in there. So the first, we're trying to clarify it. So are there multiple meanings? Get rid of that. And the same thing, multiple interpretations by different people. Try to reduce that. And the last one, that comes from, I don't know if you remember Cohen's story definition. We talked about that when we looked at user stories. But the idea was that stories should be independent. One story shouldn't depend on another story, and that way it doesn't matter what the order of implementation is. Whatever order you do, you could do any story in any order. They're independent of each other. If you were here last week when Mark German was describing how their team in Ottawa implemented Scrum, and he said, we always take a vertical slice through the whole project. So every story has a little bit of data layer, a little bit of business logic, little things. It's a vertical slice through the whole thing. And by doing those type of things, the stories become independent. You don't have to sort of say, well, we need this story first. Like, we're going to do the data server stories. And then once the data server stories, we'll do the business stories. Once the business stories, we'll do the reporting stories. That's not really how people like to do it. We try to make them independent, so you go to vertical slices through them. And these are things we look for in grooming. And sometimes the owner will come to you with a story that you might, he present it in one way, and if you start looking at it as a vertical slice, it'll come out as a totally different sounding story. It's much easier to implement and deliver value. We in grooming sessions try to improve our understanding of what it means to be done. You know, the fundamental question of all software engineering, are we there yet? Are we there yet? Are we there yet? Are we there yet? So we elicit, as we've already discussed at length in this class, story tests from the owner. People call these fit criteria or acceptance tests. Those are all, in my view, synonyms. Lovely if we can automate these things, but for every single story, we really want to know what it means to be finished. So what does it mean to have this story finished? We try to elicit story tests in the form of examples from the owner, if we can. Models we can follow, the ones we tried to do in this class, the normal flows, alternate flows, error flows, right? The normal flow, alternate flow, error flows. But there's others. We could have business rules, decision tables with business rules could be a perfect way to describe acceptance tests. Here's all the different business rules. We want to make sure we can demonstrate all of them pass after we've implemented the story. Think about insurance companies and banks and stuff like that, where you have complex transactions that depends on many, many, many conditions. So writing out every flow might not be the best way to describe the story tests in those type of situations. Business constraints, things like can't have more than $1 billion in it or whatever, those become constraints we can elicit from them. Those can be story tests. Does it violate the constraint? Demonstrate that it doesn't violate the constraint. And we can take non-functional attributes, which we've already looked at, that can be a story. The non-functional stuff can be a story. Or we can say a story has a non-functional acceptance test to it. Like, for example, the user response for a certain interaction has to be less than 8 seconds under load or something like that. So that becomes a non-functional attribute. So when you're doing grooming, what we also do is we try to, in our planning meetings, size the stories. Now the question comes up sometimes, when do we size a story? Do we size a story after we have all these story tests well defined, or before? And actually there's both ways are perfectly acceptable. Think about how much time it takes to elicit really good story tests. It's tricky, right? You can imagine it's sitting there, you might take 25 minutes of your grooming meeting or an hour just pulling this information from the product owner. And it's worth it. If you know that, it's good and you're going to get a much better estimate. But at the same time, what if when you get the story tests, you do all that work, then you estimate it, and it's just no way that the product owner wants that story implemented because it's too big. You know, if they would say, well, if it was 20 points, with 20 story point story, sure, I'd love it. But right now, it's 60 story points. That's ridiculous. It's too big. Why did I waste my time going through all those story tests on a story that I wasn't going to implement because of the size of it? So what people will do is they'll use, they'll make a sizing estimate before they have it. They'll have just a guess about what the story tests are. They're just a wild swag, a wild guess of what the story tests are. Size it based on that guess, and then if it's worth it, if the story is still interesting to the product owner, then elicit in detail. I've got customers who do it both ways. There's no big debate about it. You figure out the way that works best for you, and you're going to find that if the product owner is pretty sure of the stories, and the stories are similar to your past, you're generally better to elicit the story tests first. But if it's something way out of the blue, you might want to size it before you drill down too much, because if it's way too big, the owner might want to walk away and split it. You know, do something different with the story. So when we looked at that, we saw in the collaboration, there's techniques to do estimation. We only looked in detail, I guess, at planning poker in this class. There's all sorts of strategies. Planning poker is really a popular one, but there's all sorts of estimation and sizing strategies. What we find an important collaborative activity is to actually, in the planning meeting, advocate the size you selected. To actually tell people, hey, why did I say it was 20? Why did I say it was 13? Why did I say it was 5? And we don't usually ask everybody to justify it, but we'll take the highest and the lowest numbers and we'll ask people to explain them. So that becomes the skill of advocating the size, understanding the other's position. It's not just going to and sticking with it and saying, it's a 20 and I don't care what you say. Your job in collaboration here is to understand why someone said it's a 20 and someone else says it's a 3. So as much as you're supposed to have the skill in advocating your position, you also have to have this empathy, the ability to understand from the others. And that's hard to do. Some people, technical people, can get very stubborn because they've got their worldview and they won't move it. Well, if you keep inflexible in an agile team, you might find you're not going to be as productive, and the team might actually phase apart after a little while. So coming to a reasonable consensus without necessarily giving things up, i.e. by making trade-offs, and persuasive argumentation are all skills that come up in the sizing. And of course, towards the big stories or large stories, well, we can help in discussion to split up large stories into small stories, and this is a dialogue, reorganizing stories. Take small ones, combine them, take big ones and split them. That sort of activity is something that we'll do in grooming. So grooming meetings, there's a lot of different, how can I put it, ways we can fit them into our project plans. Most of my customers do a small grooming session every single week. And the stories they're grooming are ones that are going to be in the next couple of sprints. So if you're doing sprint A, I'll have once a week, let's say, a time-boxed grooming session, and we'll look at the potential high priority stories for sprint B and sprint C. So not the sprint A ones, those are all groomed, those are all being implemented, but we're going to be looking ahead in the future. And the cool thing about that then is that you also then get a sort of heads up as to what's in the pipeline. And that will influence how you code the current stories if you have an idea what's in the pipeline. It's going to bias you, which is actually a good thing. So, next point, planning. So planning takes place at the beginning of a sprint. Some teams will spend actually a day and a half just doing this activity, and they'll lock everybody in a room and have them do it. Now, if you talk to Mark German, now he says they do it all together, a planning meeting. But if you talked to him a year ago, he said, well, we were trying to follow more a Kanban style, different style, Kanban style. And what we're trying to do is we're trying to just look at the planning of one story at a time. If the stories are truly independent, this actually can be done. So you'll just take 2 or 3 people who are probably the principal ones involved in a specific story, and they'll do the planning for the stories. So you can get more efficient use of everybody's time. If you have 10 people, you might be wasting a bit of time. So you can split it up and say, okay, you guys do this story, you guys do that story, and then we'll put all our results together. What happened to my screen? There was an ad for Netflix that came up. I didn't even think I was on the internet here. This is amazing. Sorry about the ad for Netflix on my screen. All right, so the planning meeting is when the team gets together to identify the tasks. And I'm sure that just trying to do this, you realize how hard it is. It's easy to say, right? Hard to do. How do you break down a story into a bunch of work that can be done by people? And there's issues of what is a reasonable size of work. What is a chunk? Now, in software engineering teams that I've worked on and I've managed, I really like to see the chunks to be small, never more than a few days. From a half a day to a few days long. If something in my task list looks like it's going to take longer than 5 days, I will ask the developers or the people who are proposing that, can we split that in 2? Can we break it down somehow? And very often you'll find it can be broken down somehow. Some people actually, if they don't know how they're going to implement it, they basically just figure out how to implement it as a task. And I don't want that. I want the planning meeting to be where we've actually made the decision. Here's how we're going to do it. So we're really doing a planning and design session at the same time. It's not just one of these hypothetical, Burnside Hall Management Department Gantt charts. It's really, you're looking and saying, what is the technical work we have to do? And I really want people to jam about that and figure it out and discuss the alternatives. So the granularity, it doesn't matter what you pick. Smaller in my experience is better, but the whole team has got to really be consistent on it. And it's really, you've got to be consistent across tasks. So if you have 20 tasks in the sprint task list, and you have some of them are half day, and then some of them are 8 days. Well, you got to sort of break them down differently. You want as close as you can a uniform granularity across the tasks. So that's an important part of the planning meeting, is to agree on what the tasks are that we're going to commit to. We might even want to suggest that the tasks require skills to do them, so the task can be done by anybody in the team with the suitable skills. Tasks can be for individuals or small groups of people. They do not always have to be for single individuals. And I've got this cool customer in, you're going to love this, Uruguay. And what they do is they study collaboration in testing in Agile projects. And what they found is they get a lot of very, very good work done by pairing domain expert business gurus with professional testers. So you get a domain guru, a professional tester, sit them down for a couple of hours, and they are able to do a heck of a lot of good work. So it's two people doing the job. What about paired extreme programming, right? Where we have two developers paired all the time. So that's two people in those activities. If you have to do performance testing, you might want someone who's very familiar with the development side of it and someone very familiar with the user modeling side of it to work together. So the tasks don't have to be only one person. They could be two or more people. It's very rare I see more than two, though. Usually I see like one or two people in these tasks, but it could be even the whole team. You might have a task there, for example, to critique a user interface. So one task is prototype or mock up alternative user interfaces. So the programmer will go and mock up a few interfaces. And then the whole team will get that together, and they'll, for a limited time, maybe 45 minutes or an hour, whatever, they'll look at these and they'll critique them. So the developer can go back, rework it, and come up with a good design. What's wrong with that? The whole team gets together and critiques something. It's a task that you can do as part of design. Why not? Tasks basically involve employing knowledge of some craft. What is the craft of our work? We are programmers, we are testers, we are technical writers, we have whatever skills we need. We also have knowledge of the domain. Not all tasks need the same knowledge of the domain. Domain expertise would be whatever your vertical market is. Vertical market like books, book rules, insurance rules, healthcare rules, whatever domain you're in. There's different domain knowledge. And tasks also come out based on what your relevant experience is, which means that I was very unfair to you this term. Because I said work as a Scrum team on a project which you had no experience collaborating together on. You have never done that before, so it really takes, as I suggest, it takes about 3 sprints to actually start building that sort of experience. We don't anywhere near have the time to do that in a semester. But in a planning meeting in a commercial project, you will see people draw from their recent, relevant experience. And this is what people do. They apply that. We run ideas off of each other. We try to get some synergy going here. Try to bounce ideas off people. And there's different brainstorming approaches like that. We model. We draw pictures. We try to play the devil's advocate. We say, what if? What if this goes right? What if this goes wrong? We challenge it. And we don't challenge it because we're trying to put it down. We're challenging it to try to make it better. We're challenging it to compare alternatives. In planning, we have to make sure that the tasks that we've identified are sufficient to implement the story. And that means not only do we have to care what are the story tests, which I think is fundamental, but also we have to think of what does our team mean when we say done. So if I add a new story, and done means installable. Well, not only do I have to have a task to implement the story and a task to pass all the story tests that the owner gave us, but I've also got to have a task to say, let's update the installer, and I have to have the task saying, let's shake it down and try it on the different target platforms. Those are tasks related to what does done mean. So this is unfortunately something that a lot of people forget. We have to look at what does done mean and make sure that when we're implementing the stories in the sprint, we have considered what done means. And of course, we should also make sure the story tests work. If we are using automated frameworks for the story tests, then we should allow tasks for the programming of these automated story tests. And that might mean what they call putting in fixtures. Fixtures are code to basically hook your automated test environment to the system under test, to the application you're developing. So it's not good enough to just say, okay, we're going to implement the story test. You may have to actually have some programming activities or tasks, hooks, things put in there. So there's basically making sure that the tests work, they can run, and make sure that we can use them for future regression. When we say regression, run the tests again in subsequent builds to make sure the behavior of the system in the future is consistent with the past, so that we have a warm, fuzzy feeling in our tummy that we didn't accidentally break something. You're not proving it, you're just giving yourselves a good heuristic jump on it. We don't know for sure. So that's grooming, planning. Another thing we have in Scrum is the famous stand-up meeting. How did you guys try to implement that in your project teams? Using Skype or something, or do you actually physically get together? Chat?
We're trying to actually stand up in the hallway.
You found a hallway to stand in?
We're going to try it for this week.
You're going to try that this week. That's probably one of the better ones, if you can physically be in the same place. The stand-up meeting is one of the most important collaboration points in Scrum. Because it's where you can react to change as a team on the fly periodically. So we know that we're going to sync up at least once a day, and it's going to be short. It's going to be a meeting where all the team members are participating. It's going to be facilitated by someone who's expert at facilitating these things. The team members should accept the facilitation. It's very, very important. In the stand-up, we ask people to communicate. So there's a critical skill here. Being able to communicate your progress. So you look at the tasks that you're supposed to be working on. You say, well, which one did you finish that you're working on? Which ones are underway, in progress right now? And are there any potential things blocking you? So these are the three things that we talk about in the stand-up meeting. And the Scrum Master is supposed to, by the way, in case you're interested in where the Scrum Master fits in this, it's not just to orchestrate this cool meeting. If there's something that's impeding you, they're going to unblock it, figure it out, figure out a way for you to get your job done because something is blocking you. So this is very critical. The Scrum Master is clearing the way. It's like an offensive lineman in football, if you're interested in the positions. Give a space so that the quarterback or the running back can run through. In the stand-up meeting, we have an opportunity as a team to take a quick look at the task list. You know about this because you're programming the task. You're working on the story. You don't have to generalize. You don't have to think of everything for everybody. But the one you're working on, once you start actually coding it, once you start actually testing it, once you start actually implementing it, you are in what we call reality. And the tasks from your planning meeting a week and a half ago might not exactly match up with the tasks we have to do based on the reality at the time. You might find out, for example, there's structures in the code that you uncover that have to be modified that you didn't know at the time of the planning meeting. So during the stand-up, we should review tasks, add new ones, remove irrelevant ones, change them, refactor them based on the real work being done. And the Scrum Master's job is to keep this task list up to date to make sure that we always know what the tasks left are, because the task list will tell us if we're done with the story. When there's no more tasks with the story, generally we're done. So another type of thing that happens an awful lot in Scrum projects is what I'm calling whiteboarding. Now Scrum projects will very often the team will have a room somewhere where they do their stand-up meeting. And in this room they're going to have usually a board on the wall which you're going to call your Kanban board. It's going to be a board where you see the progress. What are the stories that are open? What are the tasks? All this is visible. And if it's not physically on the board, it'll be in a database somewhere, in a tool, and you'll project it somewhere. You want to physically see this somehow. And in this room, there's usually 2 or 3 whiteboards. And what the team will do is they will use these whiteboards to try to collaborate with each other to understand all sorts of aspects of it. Now remember, I said in waterfall projects or rational unified process projects, we have many, 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 many artifacts, right? We have many, many documents. In agile projects, we have none, right? We have hardly any. We try to do barely adequate documentation, internal documentation, just enough for us to do the job. So the whiteboard becomes an important thing for us. We use it for brainstorming, so knocking ideas around. You ever see a whiteboard with do not erase on it? I don't know if you've ever seen that in a company. Do not erase. Those are very important whiteboards. And then now we take digital pictures of them, so even if we get erased, we still have the data. But we don't have a persistent document, so that whiteboard is like worth a lot. But it's only really valuable while we're working on the story. So that whiteboard, the life of it might just be a couple of days. That it's valuable, but at that time, that might be the key reference thing. We use it for visual modeling. We do stuff like software-related design, cross-story interaction, control flow analysis, even flow charting, for example, data flow, data paths through it, block diagrams, which I think is just a wonderful skill. Block diagramming is just, for me, a wonderful skill, where you try to describe a system where you put blocks to represent blocks of functionality or processes. And of course, you can do this with Visio, right? You know the type of tools to make these block diagrams. But what's interesting is that there's 2 things. The blocks are objects, and the lines are relationships between them. And just show me a system, and name the blocks, and then show me the interactions between them. And from that, we can get a strong conceptual knowledge of what we have to do to change it, to make it better, to make it different, and all this type of stuff. So it's a very simple construct. Anybody can learn how to do block diagrams. And once you got that, that's your whiteboard. Make a block diagram. And the model has to be, all models are wrong. Some models are useful. That's the famous George Box quote on models. And here, the model has just got to be good enough for what we're doing. So you don't have to create a diagram that's got to be good for all time, so that when archaeologists come from 5,000 years from now and look at your project, they'll understand what you did. It has to be good enough for us to collaborate amongst ourselves, so you can pick a level of detail you care about. You might just put the few modules and processes you care about and just leave other stuff out. And another one I love to use on whiteboards are called lists. And they're just lists of things, conceptual lists. When I have a bunch of ideas, I make a list. And then if I'm, for example, creating a block diagram, I might have the list, and for the list I'll cross-reference the list to the objects to make sure that I didn't miss something. So people will build little dynamic checklists, which you might call to-do lists and things like that. So that's whiteboarding. We have a type of collaboration which is reviewing with end users the design. Now, we do not have a design phase in Agile projects, nor do we have a customer acceptance testing phase per se. So all these phases that all these beautiful other processes have, we don't have. It doesn't mean we can't talk to the user. If you are doing something that is going to be part of the user's experience, I'm not going to say GUI. GUI is part of it. It's the experience for the user to do their job with the system under test. That experience, you may want to collaborate with end users to critique it in the development environment. So you're in the development sandbox, you're in the team, though you're working on stuff, you bring in end users to critique the stuff. And this is very important, because when we're doing this, we want to elicit things from users, and sometimes it's very subjective what we're getting. It's sort of a gut feeling that we're getting. They're saying, well, this is awkward, or this is good. But it's not really against a rule set. It doesn't matter, because these are the real users. Or they're people who are good representative sample real users. So whatever they say, I want to sort of be able to sort of interpret that and see if there's sort of something useful in there that will help guide us. So I want to listen very carefully. I'm going to use open-ended questioning. I will try to minimize this ABC choice thing. I want to sort of have them tell me things, long statements, and then from that we'll interpret it, and we'll see how we can improve our our design. Plus, you could do it sometimes with a small focus group. And sometimes you get 2 or 3 users together looking at a prototype, and they have to realize it's not a working software, it's just some sort of prototype. And then they jam with you together as a little focus group. These meetings, they don't take too long to orchestrate, but in the middle of a sprint, it could be invaluable for you to develop useful working software. Of course, doing this involves all sorts of fuzzy human factor stuff. We have to consider different types of users. Like, do we consider, what if it's a novice user? What if it's a typical user? What if it's an experienced user? What if it's a user with, for example, a lot of professional experience, but very little task experience? Now, task experience means the experience to doing this type of task, and the professional experience might be their domain experience. I've been in the insurance business for 30 years, but this is the first time I use a smartphone to buy an insurance policy. So we have new at the task experience, but rich and high on the professional experience. So if you look at professional experience, high, medium, low, task experience, high, medium, low, there's actually 6 possible combinations of those. So when you're reviewing end users to say how do they enjoy user experience, it's a good idea to consider different ones, different levels of professional experience, different levels of task experience. It's important to do this directly to get the user actually touching prototypes of the software, although sometimes you can do this with mock-ups on paper mock-ups and things like that too. We want to be able to do this whenever we need in the sprint. So if there's a need for end-user reviews, we want to make sure while we're developing software, we've already identified some of these end users so that we can call them and say, hey, this afternoon can you come over for an hour or two to take a look at a screen with us? And they're available to do it. It's not like we have to spend 3 weeks finding the user. I mean, what's the point of that? So you have to be able to do this on the fly, on demand, whenever it's needed. We spent enough time this term looking at test-driven development. I don't want to dive into it too deep, but test-driven development is a collaborative activity, to be sure. It's when we program, starting with the low-level tests of what we're going to be doing. The collaboration activities that fit here. A, brainstorming what tests would be required to implement the function. So if the developers have decided we're going to program this function, it might be a good idea. In fact, I strongly recommend talking to at least one other person to brainstorm on what is a rich set of tests. You want to be careful. You start with a huge bias. The bias most developers start with is that their design will solve the problem. I want to challenge the design. I want to challenge the design to see if it solves the problem. So that's why getting another point of view helps you get out of that bias. There's nothing wrong with your design bias. I want you to stick with your designs and believe in them. But I'd love you to just get ideas for test-driven development from not just from you, but from someone else either. Otherwise, you're just going to be confirming your design does what your design does. Not necessarily your design does what it should do. So you want to get other ideas. And then there's the notion of mapping out the order of tests. Some people say that's a very personal thing. Other people say, well, you want to brainstorm it off of people and look at different pathways through these tests to implement the code. Another part of this is just test design. If you have a team with some people with a lot of skills in test design, it's probably a good idea to have them coaching the developers in test design approaches that might be applicable for the TDD. All right, so that's test-driven development. Big collaborative activity. There's pairwise testing. Pairwise testing is generally when we take 2 people working together to exercise a chunk of software under development. So it's 2 people working together, and you usually time box this. The typical session time that I use is between 90 minutes and 2 hours. So you have a piece of code. You're usually in the developer sandbox here. It hasn't been checked in yet. It's being worked on. And you want to exercise it from a certain perspective, from a certain point of view, for a certain reason. So you have 2 people working together, and they spend that time studying the code, and then they find bugs, problems, concerns. After the time is over, the buzzer goes, we stop looking, and we decide what to do. Do we have enough information? Should we continue another session? Or should we act on what we found so far and move on to something different? So these are the type of things we do in a testing session. We can pair with different people. My Uruguay case was domain experts. So you are a technical project team member. You are not a domain expert. You don't have a PhD in whatever the topic area of your software is. Once in a while, it's handy to do that. When I worked at my virtual model, I had to set up all sorts of testing for fashion servers that estimated, given your model, estimated what fashion size you had. And there was no way we could deterministically figure that out. We had to sit down with a fashion expert for a period of time to make sure that we were correct. So strategies to assess correctness, have an expert with you, domain expert. It's very handy in some cases. Non-functional testing experts. There's a lot of nuance in all these non-functional tests. Remember the term I use, the ilities. Usability, reliability, maintainability, availability, scalability, portability, all of these words with ilities, including, by the way, security, performance, and load testing and stuff like that. These are non-functional tests, very critical things, and it's very rare that you're going to have everyone in your team has the technical skills to do that. You might have to get an expert in, a non-functional testing expert, to pair with you for that. Pairing with developers is fantastic. If a developer just wrote the code and they understand the technical risk, you pair with them. Or pairing with other testers to sort of share experience. So paired testing is an important collaborative effort in the sprint. Something that related to that is called the bug isolation. Bug isolation is basically when programmers and testers work together to try to understand a bug. Now, what are we trying to understand about it? Well, that could be a lot of things. One of the most common things people try to understand in bug isolation is how to repeat it. But sometimes you're not interested in how to repeat it, you're interested in what its scope is. Does this bug just impact this piece of software, or does it impact everything? So there's a lot of different reasons why you'd want to study and understand a bug, to isolate what factors matter in it. Often we're trying to learn how to repeat a bug, or under what circumstances the bug appears, or otherwise collect meaningful information about the bug. So bug isolation, a nice fun activity. Related to it is troubleshooting. You ever used the term troubleshooting around here? I'm sure if you took a lab course here and you tried to get the electrical engineering lab courses and tried to get your circuit working, then the TA saying, did you troubleshoot it? Troubleshooting it is not just isolating the bug, it's trying to understand the cause of it and fix it. So this is troubleshooting. Troubleshooting is a wonderful thing. In Scrum, we see this a lot. It's fantastic. You don't bother having a whole phase of development for testing in the heat of the sprint. When the tester is working in the developer sandbox, if there's a problem, the two of them are there. The developer will work with the tester. They might do what-if analysis, hypothesis. I assume this is the problem. I change the code. I see if the problem is right. If not, I change something else. I go a tight loop like that. That's one way you might be able to do debugging. And you might put, for example, assertions in the code. The term assertion come up a lot in other courses. I don't know if you learned about assertions? No? Assertions in code. Just a piece of code you chuck in there. And all the code says is, if you're running this line of code now, I should be in this state. If I'm not in this state, this is an inappropriate state, therefore I'm going to trip an assertion. So an assertion is a piece of code that's going to tell you we're in the wrong state. There's actually some tools that allow you to do this very gracefully, but you can even do this yourself. Just putting code in there to say, is the application in the right state when I'm running it? Or are variables in the right range of value? Or is there something about the code that's out of the control of the developer? I like to say the out of control from the developer. Somehow we're executing code that's not supposed to be executed right now. It's gotten somewhere else. There's also troubleshooting, which is more model related, where we go back to scientific evidence-based analysis and we create models and we design experiments to refute refutation and confirmation of models. I believe it's Mills who came up with the scientific method around that. I'm not sure of the history. We basically try to learn, observe attributes during execution, come up with better models. So this is one thing we can do. Apply experience. Oh, the last time we had this bug, it was because this type of file was that. So you take your past experience, you say, this is what leads to these failures, and try it out, see what happens. So, troubleshooting, very important part of collaboration. Effective teams are very good at troubleshooting, and it's almost always best to have a couple of people doing it at the same time. A demo. At the end of the sprint, we have a demo, and generally the demo is from the team to the owner, so that's the collaboration there. We show implemented stories, we show the tests passing, and we show the relationship between new stories and existing functionality. So this is the type of thing we're doing in a demo. we also try to show the story is done. Whatever our definition of done, whatever the criterion, we want to demonstrate to the owner that it's done, whatever done means. Now the demo might seem to be a trivial thing to do, and I just think it's a very important part of collaboration. I think you're showing professionally to the product owner that you've done things. You're trying to make sure that your understanding at that time is consistent with your understanding from the grooming meeting. So this is closing the feedback loop. Now, anytime you had to make a trade-off between when you had that grooming meeting and when you had that demo, if the trade-off affected the story tests or anything related to the definition of done, the product owner would have had to be involved in the decision. Therefore, there should be no surprises in the demo. But sometimes you're going to get surprises, and that's the opportunity. Now you're getting, maybe you got a process you got to change. You got some inconsistency, and so you'll be able to better groom stories later. So here in the demo meeting, you have an opportunity to improve your future grooming, in my opinion. Another type of meeting we have, now these are very often immediately after the demo. People will do this like 10 minutes after the demo. They'll have a retrospective, and in the retrospective, the team meets to learn from the experiences of the recently completed sprint, improve our process, identify what worked, what didn't work, what went well, what didn't go well, what screwed up, what didn't screw up, and why, and we try to understand that. Generally, my rule of thumb is to identify process improvements. I challenge every team I've ever worked for or with to have at least one process improvement at the end of every iteration or cycle of development. This is my sort of rule of thumb. Change something, monitor it, see if it made a difference. Don't change too much at the same time, but always change a little bit. So that's the retrospective. Does any of your teams have bug scrubs? Bug scrubs. There's a type of meeting in some agile teams called a bug scrub, in which the team members get together and involve the product owner to decide what to do about bugs. Now these are bugs that are contentious issues. They're bugs that we want to make a business decision, should we fix it or not. I'm assuming it's not a bug saying that the story test fails, because if the story test fails, we have to fix that. So I'm talking about bugs that might have a little bit more of a subjective element to them. Do we fix it now? Do we fix it later? Do we not fix it? Do we make a bug into a story for future sprints? Do we document the workaround for it? This is the type of things we'll decide in the bug scrub. We generally look and try to understand what's the impact of this bug, especially what's the impact if we decide not to fix it. What's the relationship to other stuff, and generally we try to advocate the bug. When I'm talking about advocating a bug, I want to use language with the product owner to try to give them reasons that we should fix it. I don't want to give them reasons why they shouldn't fix it. I'm going to argue for the bug. That's bug advocacy. Not everybody follows that pattern. So, other types of collaboration. The extreme programming, paired programming, where you have basically two programmers writing code together. Has to be people who actually get along with each other. The notion is you have one keyboard and two screens, and every line of code that's written is critiqued by another person, and you swap roles from time to time, and this fits nicely, by the way, with test-driven development as well. I've met people who do this. I've met people who tried, and they said they're never going to do this again in their lives. You really, really have to get along well with your paired buddy on this. If you don't, the process just doesn't work. It's like one person watches while the other one programs, and then you switch roles. It's not very productive. Think of the dynamic of you're sort of shooting ideas off each other, and then you're programming and trying it out on the fly. That sort of dynamic is what we're looking for. So that's collaboration. A type of collaboration that actually I think is almost universal, although there's nothing in the books about this, not the books about agile development. It's called buddy checking. A buddy check is an informal peer review. An informal peer review. It's an informal peer review you do whenever you check in an object, a piece of code, or whatever you're creating, data, documents, whatever you're creating, and before you check it in, you basically review it. So it could be code, documentation, tests, whatever we're creating. When it's checked into a version control system, just before you check it in, we basically spend between 5 and 10 minutes taking a look at it. And what you'll do is you'll have a peer, that's one of your teammates, Review the delta. Review what's changed in this object since the last time it was checked in with the author. And you might have a checklist to follow. You might have different things you're going to look for. You might have little types of things you want. We're concerned about, for example, maintainability. Now, if you know every time you write a chunk of code that another human being is going to read that chunk of code before you check it in, just because of that, you will write your code in a more maintainable style. You will take that extra effort. So just doing the peer review psychologically has that impact on coding. It really causes people to write the code a little bit more maintainable. Maybe not the better design, but cleaner, easier to change code. Buddy checks have been things that I've been doing since the dawn of time. It's independent of the life cycle, but it's something that we see very, very common in Scrum. So whenever you finish something, before you check it in, you hang out with a peer, and you double check it. You read through it with a peer, and what you're trying to do is just make sure that it's clean. Is it understandable? Is the scope of the change okay? Did you change more than you had to? Were there anything missing? Omissions? What if challenges? So I'm reviewing your code. I'll look at the change you made. I might say, well, what if the file system is not is a remote file system that's dismounted? What if the database server dies? What if there's a timeout here? What if there's a system failure? There's all these what if questions you can ask to challenge the code. And we can also do things like confirming, do we conform to standards? Confirm that the unit tests that are being checked in with the code seem to be sufficient to exercise the functionality. This is beautiful things we can check at doing an informal peer review. Other collaboration points. Your project teams this year are not interacting with other project teams. In commercial software development, we interact with other teams all the time. We receive objects from them, and we give objects to them. So basically, whenever we interchange objects with other teams, we have to work with them to accept these objects, and that's basically a collaborative activity. What if we have multiple Scrum teams that have a shared object? So the 10 teams are sharing the same object. The protocols behind that, or what if we receive objects from third-party suppliers or vendors? And the way that people collaborate there are very often a teeny bit more formal. Just a teeny bit more formal than you would have for something within your team. Because you cannot, in your retrospective meeting, change the process of another team. You could only really change the practice of your own team. You can make a recommendation to the other team, but you can't really change how they develop things. So what I like to do is for any object that I know I've got to interact with another team, to define something like what we would call a smoke test. Some sort of basically test or checklist or something that the guy giving me the object does before they give me the object, and when I get the object, I do the exact same check when I receive the object. Now, if they do that test, and it passes, they give me the object, and I do the same test and it fails, we have a build integrity problem with the object. So we don't accept the object, and we try to figure out what's wrong with our checks. So the idea is basically don't just accept it. Don't just say, hey, someone sent you a new version of this object library, plug it in and start using it, and then you're troubleshooting and debugging for the rest of your life. Have a mechanism to accept something that you're receiving from the team. And then make sure there's two sides to it. It's a handshaking protocol. And this is the way I've done it. So again, it's a little bit more formal than what you do if it's within your team. Like if Fred develops some code one day and I'm using it the next day, we don't have to have a fancy smoke test between us. We're all in the same team. We get along together, we know what's going on, we peer reviewed our code. But some other team 10 blocks away, who we don't deal with except by sharing this object, we will be very careful about that. So that's collaborating with other teams, third-party vendors, and stuff like that. Smoke testing is just one mechanism. It doesn't really matter what mechanism, it matters you have one. Let's see. Another type of collaboration we see, the notion of the Scrum of Scrums. Let's say you're in a company, so one of my customers in Montreal is called Autodesk. You know Autodesk? They make AutoCAD, those type of software. They have something like 24 teams working on in parallel. 24 different teams doing Scrum at the same time. Not all with related code bases, but they're all working at the same time. And basically they have a Scrum of Scrums. And what happens is, I believe it's every day, all the Scrum Masters from these teams get together and have one of those short stand-up meetings. And it's just a stand-up meeting about issues, inter-team related issues. that they're dealing with. But this is called a Scrum of Scrums. So the Scrum Masters from different teams meet to coordinate work. They review cross-team issues. It's very, very similar to your stand-up meeting. They call it a Scrum of Scrums. Now there's some collaboration points I want to share with you. There's a few of them here that do not follow what someone would call is dogmatic agile development. So it's breaking some of the principles. But these are things that people really do. So I just want to share with you a few of these collaboration points. One of them is called an architectural review. Now, if you follow pure agile thinking, we don't have an architecture, we have an emergent architecture. So an architecture is something we discover as we go. We don't know it up in front. We don't spend 2 months designing our architecture and then implementing it. So an architectural review is a bit of a scrum butt here just because of that. But the cases I've seen where they do this is companies that have frail legacy code. Now, legacy code is old code that's been there for years and years and years, that the person who wrote it is long since gone, that you hardly know how to build it, and that if you have to change it, it's very delicate stuff. So imagine someone just gets hired there, you have to modify a piece of code that was written 15 years ago, and no one really knows how it works, and it's very delicate, what we call frail code. It's also very often code that we can't automate the testing of, because there's no hooks in it. So it's old code that we really don't want to touch that very much. Well, what some companies do is they will take that code and they let you modify it, you do your work on it, you modify it, but before you check it in, you take the code and you submit it, so you take it to, it's like a black box, right? You take the code and you put it in this black box, and it comes out of the black box with a list of things that are things you might want to change or adapt or tweak or something like that. And the mechanism that's used here is that you have these wise architects, people who are the sort of sage gurus who get together and collaborate with each other to critique your code based on their knowledge of this historic wisdom and architecture that very few people know or understand. And the whole point is to inspect it to make sure that we don't make the code any more frail than it has to be. We're trying to catch introduction of legacy bugs. There might have been a bug there for years that we don't want to change. This should be a quick turnaround. So in other words, when I say it's a black box, from when you put the code in there to when you get the feedback, it's got to be quick. It can't be 3 weeks of review. It's got to be like minutes or hours to do. So it becomes very important to turn it around quickly. So another thing that people do sometimes is they coordinate shared code. I hate when this becomes an issue. Some organizations cannot implement nicely branching and merging in source control systems. You're familiar with branching and merging? I know Bruce was here and talked about source control and branching. So you work on something, you branch off, you make your changes, then you merge it back in. In continuous integration, we try to merge it in as quickly as we can so that we don't have dangling stuff that's not on the main code line. Some companies have a great deal of difficulty doing the merging, and so if you have a shared piece of code between multiple teams, and there's a company in Ottawa, not Ottawa, Toronto that I worked with, I believe it was 4 teams using a common code base. And I went through this one day. I spent a lot of time there. I was auditing their Scrum meetings. I went to, in one day, 4 different sessions. Every single session, everyone was complaining about this common code that some team modified that mucked up the behavior of all the other teams. And their big problem was that they did not make branches, get it working, and then merge it in later. So they were modifying it live. The next time the other team built it, it screwed them up. And there was a huge problem. The problem was one of coordination of shared code. So if multiple teams are using shared code, it's very important to have a way to coordinate the changes to the shared code across many teams. If you hand off to other teams, let's say that your team develops code and gives it to another team that's going to test. Again, that's a scrum butt. Your team is supposed to have done stuff. But some companies will say, well, we can do done, but we can't do done. That last done is platform compatibility testing or some other type of testing that you can't do in the sprint. So when we're handing it off, we need the way to collaborate. How do we hand off? How do we know what to give them? And if they find a problem, how are we going to deal with it? So the cases that we've seen, so hardening sprints are simulating extra testing in some context. Non-functional testing sprints are when you have a heavy metal, usually performance and load testing, that you can't do every day. It's very expensive, very costly, so you need a lot of capital equipment to do that. And integration sprints are sprints designed to take the works of multiple teams and integrate them together. So in these cases, we need to have protocols to coordinate with the different teams. So that's my rant about collaboration. There's other points of collaboration. I don't know if you want to suggest a couple that you see in your project teams. Where do you see points of collaboration in your team? Stuff that I didn't mention that maybe you guys face. There should be one that you do. Timing, right? You have the issue of everybody has a different schedule. I'm assuming that everyone has a different schedule, and the schedules involve doing things like, I don't know, some of you might go to classes sometimes. You might also do projects or labs. You might have to go to job interviews somewhere with the tie there. Was it Microsoft? No, because it was Microsoft and you came here. I'm honored, because people very often, they don't come because Microsoft interviews them. So there's timing and coordination of your scheduling. That whole logistics becomes a big thing in here. Now, if you're all in a team that's sort of sitting together on a floor in Place de Marie, working within a cube or two of each other, you don't have to go and have a special coordination for that. But for your teams this term, or for any time you have distributed teams, we have now logistics coordination, scheduling coordination, stuff like that. So that's one that I can think of that in your context you'll have that in a lot of commercial contexts. That's going to be, if it's there, it's going to be very transparent to you. It's going to be something that is sort of built into the framework around which you work. So, that's all I want to say.
What about last minutes where one person, emergency, can't make it late, but things move back? How do you collaborate where you have someone else to support?
So, in the sprint, if you have a task, and there's someone who's supposed to do the task that can't do the task, right? And the reason they can't do it was unpredictable in the planning meeting. So some catastrophe happened or something. I break this down into 2 or 3 patterns. So if it's a technical thing, for example, a technical uncertainty, and suddenly you see something that you thought feasible but is not now. For example, I always say teleportation. So we basically, we're going to implement a story, we thought we can teleport someone, and we haven't, we can't do that. Or time travel, we can't go back in time. We thought we could, but the flux capacitor was only in the movie. So what we have to do, in that case, we find a technical thing that is reasonably impossible to do, practically. I mean, technically it might be possible, but not within our constraints. At that time, the whole story is in jeopardy. Then you can step back and say, are there other designs to implement the story? If so, the team might refactor their work to just take that task out, but also take all the tasks related to implement that story that way and redo it. So you have a mini planning meeting to fix that, if that's possible. But frankly, it sounds like the case you're saying is it might be a little bit more like it's too late to redesign. No, but in general, it does happen that someone dies or gets hit by a bus or can't make it, right? I mean, if something weird happens like that, and that was the only person with the skills to do this type of task, and you don't have a contingency, which you probably don't in a Scrum team, you're relying on each other, one of the risks we have is that then you got to pull the owner in. And you got to say, hey owner, this happened, would like your blessing to pull the story from the sprint. And the owner will, if it's late in the sprint, probably tell you, okay, pull the story. We have to have a working story here. I've seen also the sprint canceled completely. Because an owner might say, well, I need a set of 5 stories working. We'll call that a story set or a feature list. We need, and if you have 4 of them, it's useless. I would have rather a different 5. And in which case, what you do is you cancel the sprint, and then you'll start a fresh sprint with new stories from the backlog. The owners have to do that. It's a perfectly legitimate thing to do. It takes nerves of steel for a product owner to do that, but it's sometimes the right thing to do. Now, again, we've got false reasoning here. Some people make decisions based on what's called sunk cost. And sunk cost means I've already blown all this money in it, I already did all this work on it, therefore I'm going to keep going because of that. But the sunk cost thing is really false reasoning. You should be looking at the forward work. So from where I am, what do we have to do to finish things? If you've got a good granularity, you'll catch these things very early. Even in the planning meeting, you'll catch some of this stuff. You'll catch these problems before you even start coding. And then, if it's the first day or 2 in the sprint, you get the owner involved. You just go and reprioritize the backlog a bit and fix it. It's very, very cool to do it in the first day or two. If you find it the third week of a 3-week sprint, it's sad. If it's it's sad, unless of course someone gets hurt or something like that, and you don't have a contingency. The ways to involve it, you'll look afterwards. You'll see how can we avoid that in the future. You might figure out another strategy of programming, or you might say for certain types of tasks, we've got to make sure that we have backup people who can do it. In a sprint, though, if let's say you know a contractor, like you're doing Oracle database stuff, and you're not Oracle gurus, but you need an Oracle guru, so you go and you find an Oracle consultant. Now, to get a consultant in from outside, never seen your team, get them to work productively up to speed, it might take several weeks. You can't practically do that in a sprint. So it's very hard to sort of just replace people in a sprint. Sometimes canceling the sprint is the best thing to do in a case like that, like when a person isn't there. But if it's technical infeasibility, I challenge the team always to look at different design alternatives. And I encourage people, when they're designing anyhow, to always have at least 3 alternatives. Now, if one of the alternatives you chose fails, you've already thought through 2 other ones. So flip to plan B. Well, we're not going to do this, we'll do something else. But that's the real world. This does happen, and hopefully it's very rare that you'll have to cancel a sprint, but it's better to cancel a sprint than to just keep going to something that's absolutely unachievable. Or you pull the story, of course. If the owner is acceptable, you just pull the story. Right? Good question? Other questions, or I'll call it a day? So next week we'll look at failed sprints, failed Scrum. Not just the sprint, the whole Scrum. What not to screw up. Have a good week, guys.